Welcome to this video on multiplying polynomials. Let's begin. In example 1, we're actually going to start with not a polynomial, but a monomial. So let's multiply a monomial by another monomial. In this example, we are going to be using the product rule of exponents, which tells us to add the exponents. So I invite you to remember that 4x cubed y to the 4th z times 2x squared y to the 6th z cubed, all of these values are connected through multiplication, and multiplication is commutative, meaning that the order doesn't matter. In other words, 2 times 3 is the same as 3 times 2. So the first thing I'm going to do is I'm going to rearrange these values so that values with the same base or constants also are next to each other. So in other words, I'm going to rewrite this as 4 times 2 times x cubed times x squared times y to the 4th times y to the 6th times z to the 3rd power. And then for this z right here, I'm going to put a 1 here because z is the same as z to the 1st power. Okay, so let's keep going. So we have 4 times 2 is 8, and then for the rest of these, we are going to be using the product rule. So we have x cubed times x squared. Again, the product rule tells us to add those exponents. So 3 plus 2 is 5. So we have x to the 5th power. Okay, for our y terms, we have 4 plus 6, which is 10. So we have y to the 10th power. Okay, and then last but not least, we have z to the 1st power times z to the 3rd power. So that's going to give us z to the 4th power. So our final answer is 8x to the 5th, y to the 10th, z to the 4th power. So before we continue, let's briefly review like terms. Two terms can be combined, and here by combined I mean using addition or subtraction, only if they are like terms. Like terms must have all the same variables raised to all the same exponents. So let's really quickly do a few examples. So for example, if I have 2x and 3x, right, they have the same variable x, and in both cases x is being raised to the 1st power. If I had 2x and I had x squared, right, those are not like terms because they don't have the same exponent. If I have x to the 3rd and I have 3x to the 3rd, these are like terms because they have the same variable raised to the same exponent. Over here, if I had x to the 3rd and x to the 4th power, I could not add or subtract those terms because they are not like terms. What if I had a few variables? So let's say I have x to the 3rd y, and then I have 4x to the 3rd y. Okay, so again, even though they have different coefficients, they have the same variables, x to the 3rd and y, and x in both cases is raised to the 3rd power, y in both cases is being raised to the 1st power. Okay, let's compare that over here. What if I had 1x to the 3rd y, and then I had 4x to the 3rd y squared? So in this case, everything is the same except for if I look at my y terms, or my y values, right? In the first example, in the first term, y is being raised to the 1st power. In the second term, y is being raised to the 2nd power. So I could not combine those. So again, every single variable, they have to match completely, and the exponents must also match. All right, let's keep going. In this example, we are going to be multiplying a monomial by a binomial. Binomial means there's not one but two terms. And monomial, mono stands for one, so that means one term. So in this case, what we're going to have to do is we're going to have to use the distributive property. So we are going to be multiplying 2a to the 3rd b times 3ab squared. Okay, and then we're also going to multiply 2a to the 3rd b times negative 4a. Okay, so just as we did in example 1, we can rearrange these values so that values with the same base are next to each other, and then it becomes more obvious how we should proceed. Okay, so that's what I'm doing right now. Okay, so we have 2 times 3 is 6, a to the third power times a to the first power. Remember, we add those exponents, so 3 plus 1 is 4. Then we have b to the first power times b to the second power. 1 plus 2 is 3. Okay. On the other side, we have 2 times negative 4, which is negative 8. a to the third times a to the first is a to the fourth power. And then we just have b to the first. So I put it all together. I have 6a to the fourth b cubed minus 8a to the fourth b. Okay, and I'm going to just leave the b as it is and not write b to the first power. Okay, so if you're wondering about my signs, remember adding a negative is the same as subtracting. So if you express your answer as plus negative a to the fourth b, that is also completely valid. All right, so now we want to do a brief review of negative exponents before we launch into multiplying polynomials by each other. So just as we did in the previous example, we are going to be distributing, meaning we're going to multiply both terms inside the parentheses by 5a to the negative second power b. So we have, negative 5a to the second power b times 2a to the negative third b to the negative first plus negative 5a to the negative second power b times 3ab to the negative second power. Okay, and just as before, I'm going to rearrange my terms or my values so that it becomes more obvious how I need to proceed. And wherever I have a variable that doesn't have an exponent, I'm just going to artificially put a 1 there. Okay, so then we have negative 5 times 3 times a to the negative second power times, times a to the first power times b to the first power times b to the negative second power. Okay, so we're going to have 5 times negative 2, that's negative 10. We're still applying the product rule here, so we're adding our exponents. So negative 2 plus negative 3 is negative 5. Here, 1 plus negative 1 is 0. And remember, anything raised to the 0 power is just 1. So this is just going to become 1. Then we have negative 5 times 3, that's going to be negative 15. Then we again add our exponents. Negative 2 plus 1 is negative 1. Okay, and here 1 plus negative 2 is again negative 1. Okay, so let's write this a little bit more simply. We have negative 10a to the negative fifth minus 15a to the negative first power b to the negative first power. Again, remember, plus and negative is the same as subtracting, so I just wrote it more simply. Okay, now we would be done normally, right? However, remember our directions say to use only positive exponents. So we have to remember our rule with negative exponents. So the deal is that if I have a to the negative m power, that becomes 1 over a to the m power. Okay, and this is the property that we're going to be using. So I'm going to have negative 10 divided by a to the fifth power minus 15 divided by ab, or a to the first, b to the first. Okay, so this is going to be my final answer. Okay, so let's do one more practice problem where we're multiplying a polynomial by a monomial, and then we'll move on. So once again, we are using our distributive property here. And remember, a good idea in all of these videos is to pause the video when you feel like you have a handle on it, work the example by yourself, and then see if you are correct. So we're going to have 4x to the third times 5x squared minus 4x to the third times 2x plus 4x to the third times 5. So again, if you want to take this extra step, you can reorganize things so that the values that have the same base are next to each other, and then also the constants are next to each other. Okay, so this is going to give me 20x to the fifth power minus 8x to the fourth power, remember there's a 1 here, plus 20x to the third power. And that is our final answer. Okay, so again, I just want to remind you guys that we apply the product rule when we multiply terms. So in other words, a squared times a to the third, right, that's going to give us a to the 2 plus 3 power, or a to the fifth power. And in general, a to the m power times a to the n power is a to the m plus n power. Okay, so this is, again, an example of the product rule. But what if we were to add two terms, such as a squared plus a to the third? What would the result be then? So I want you to pause the video, write down your guess, and then unpause it to see if you're correct. So I want to invite you to remember that when we add terms, right, we have to, in order to be able to combine them, right, we have to have like terms, meaning they have to have all the same variable raised to all the same exponent. So my question to you is a squared and a to the third, are those like terms? Absolutely not. So there's nothing we can do here and nothing we can do here. Okay, so please, please, please be careful. Okay, so again, when we multiply something like this, a to the m times a to the n, we can apply the product rule of exponents. Notice there is no addition rule, right? There isn't any addition rule of exponents. So again, unless I tell you what a, m, and n are, there's nothing you can do with the expression a to the m power plus a to the n power. So be careful with that. Okay, so we're finally getting to the part where we are multiplying two polynomials, so a binomial times a binomial. So there are two different ways that I teach this. One is you can use FOIL, okay, and then the other thing that you can do is you can just distribute. Okay, so it used to be when I taught this that almost everybody knew FOIL and was very comfortable with that. In the recent past, in the last few semesters, people have never even heard of FOIL. They don't know what I'm talking about when I teach it. So, and when I ask, I teach both methods and I ask for their preference, they actually like the second method better. So I'm going to very briefly go over FOIL. I will show you in this example, and then for the remaining examples, I will stick to this second method. Okay, so FOIL is not just something that you can wrap food in. In this case, it's an acronym. It stands for first, outer, inner, last. Okay, so when I say first, what I mean is the first terms in both polynomials. Okay, so so if I multiply x times x together, right, that's going to give us x squared. So those are our first terms. Then what about outer terms? So outer terms is exactly what it sounds like. The x and the negative 3y are both on the outside of our parentheses. So the outer terms would be x times negative 3y, which is going to give us negative 3xy. Okay? The inner terms are the opposite of the outer terms, right? So that's what's inside. So what's inside of the parentheses, or the inner terms rather, are 2y times x. So that's 2xy. So a quick note here. What if I had written this as 2yx, right? Because that's what it looks like. So a general rule, and this is true regardless of if you use FOIL or any other method, this is still true. Okay, we need to put our variables in, you guessed it, alphabetical order. Okay, and you might think that this is unnecessarily, tedious, but the reason is because these are actually going to be like terms that we can combine, right? You can see that they have all the same variables raised to all the same exponent. But if I wrote 2yx, right, visually it's not quite as obvious or apparent that these are like terms that can be combined. So just to help yourself be able to quickly recognize like terms, if we put all of our variables in alphabetical order, if we follow this rule, it will make our like terms much more visually obvious for us. Okay, so last but not least, we have our last terms. So again, exactly what it sounds like, the terms that are on the right side in our parentheses. So we have a positive 2y times a negative 3y, and that's going to give us negative 6y squared. Okay, so again, just to recap, we have our first terms, right? That's our f. We have our outer terms. We have, so that's the o, and then we have I, that's our inner terms, and then we have our last terms, and that's our L. Okay, so let's go ahead and finish up this problem. So our answer is going to be x squared minus 3xy plus 2xy minus 6y squared. So remember what we said, the two inner terms are like terms. So we're going to have x squared minus 3xy plus 2xy. Well, negative 3 plus 2 is negative 1. So we have x squared minus 1xy minus 6y squared. Okay, if you're doing written homework, that's absolutely fine for your final answer. Sometimes the online homework doesn't like this 1 here, so we could write it even more simply as just x squared minus xy minus 6y squared. So that is our final answer. Okay, so as I mentioned at the beginning of this problem, right, there are two methods to do this. So there's FOIL, which I just demonstrated. So now I'm going to erase everything I've done and do the distribution method. So let's see what the distribution method looks like. So we have x plus 2y times x minus 3y. Okay, so what we can do is we can actually rewrite this as x times the quantity x minus 3y plus 2y times the quantity x minus 3y. And then when we rewrite it like this, we just have two problems where we're distributing. So in this part, right, we're distributing the x. So we have x times x, which is x squared. Then we have x times negative 3y, which is negative 3xy. Again, remember that a good strategy to help yourself recognize like terms is to always put the variables in alphabetical order. Okay, so we have minus 3xy. Then over here, right, we're going to have 2y times x. Again, of course, you could write 2yx, but I prefer to write it as 2xy to help myself be able to visually identify like terms. And then, last but not least, we have 2y times negative 3y. So 2y times negative 3y, well, that's going to be 2 times negative 3, which is negative 6. And then we have y times y, which is y squared. So we're almost there. Again, we have our like terms in the middle. So negative 3 plus 2 is negative 1. So we have x squared minus 1xy minus 6y squared. Or again, you could write it as x squared minus xy minus 6y squared. Okay? So again, this is based on my empirical evidence. The method that is more preferred. So in the remainder of the examples, this distribution method is the one I will be demonstrating. Okay, let's go on to the next example. So notice in this example we have a binomial, meaning two terms, times a trinomial. So another reason that I prefer distribution method over the FOIL is because FOIL only works if you have a binomial times a binomial. As soon as you exceed two terms in either or both polynomial, the acronym and the procedure kind of falls apart. Okay? So in the distribution method, I'm going to rewrite this as 2x times the quantity 4x squared minus 7x plus 3 minus 5 times 4x squared minus 7x plus 3. Okay? So once again, we're going to use distribution. So we have 2x times 4x squared minus 2x times 7x plus 2x times 3. Okay, so let's go ahead and simplify this. So remember, anytime you don't have an exponent, you can put a 1 there. So 2 times 4 is 8. X to the first power times x to the second power is x to the third power. Then we have 2 times 7 is 14. And 1 plus 1 is 2. 2 times 3 is 6. And then we just have x to the first power. Okay, so now let's do our second distribution. So as you can see, I sort of ran out of room, so I'm going to do this up here. So we have negative 5 times 4x squared minus 5 times negative 7x minus 5 times 3. Okay, so negative 5 times 4 is negative 20. So we have negative 20x squared. Negative 5 times negative 7 is positive 35. So we have positive 35x. And then negative 5 times 3 is negative 15. Okay, So, unfortunately, we're not quite finished yet because we probably have some like terms floating around in this expression. So let's start with x cubed. Do you see any other terms that have a cubed in them? I don't, so I'm just going to write 8x cubed. Okay, so remember we also always work in descending order of exponents. The other thing to remember is that the sign in front of the term always goes with the term. So for example, this is not 14x squared, it's negative 14x squared. So we have negative 14x squared minus 20x squared. That gives us negative 34x squared. Okay, moving along, we have negative 6x to the first power plus 35x to the first power. So that's going to give us plus 29x, or x to the first power, however you want to say it. And then I think that all we have left is this minus 15. Okay, so this is our final answer. We have 8x to the third minus 34x squared plus 29x minus 15. All right, in this example, this is kind of interesting, right? Because we have a binomial, but we also have a constant on the outside. So I want you to think about what would you do first. So pause the video, make a mental note or write it down on your paper, and then unpause the video to see what I say. So you actually have a few options. You could multiply by 3 first, or you could distribute first. Okay, so it's really up to you. I am going to suggest that we distribute first. Again, it's totally up to you. So in other words, if we have 2x minus 4 times x plus 5, okay, I'm going to do that first. Again, you can do FOIL, right? First, outer, inner, last. If you prefer that method, please do that. That is totally fine. I would only recommend that you don't oscillate between the FOIL and the distribution method. Maybe pick the best one that works for you, that makes the most sense, and stick with that method. Okay, so if I'm using the distribution method, I'm going to have 2x times the quantity x plus 5 minus 4 times the quantity x plus 5. Okay, now a good thing to do, even though it's a little bit annoying, is to still write this 3 here. Okay, because that way we're not as much in danger of forgetting that it's there at the very end. Okay, so the 3 is still there, he's hanging out. I put brackets there just to help me organize visually what I'm doing. Okay, so let's go ahead and do our distribution. So we have 2x times x, that's 2x squared. 2x times 5 is 10x, okay? Then negative 4 times x is negative 4x. Negative 4 times 5 is negative 20. Okay, so now, just as always, we need to combine our like terms. So we have 10x minus 4x is going to be plus 6x, okay? And again, right, thanks to my brackets, right, I still have that 3 out there. So what I can do is I can now, right, multiply everything in the parentheses or the brackets. You can use whatever you want. Multiply everything by 3. So that's going to give me 6x squared plus 18x, minus 60. There we go. Okay. So what if I had decided to multiply by the 3 first? Okay, so let's see what that would look like. So here's a brand new page. So we have 3 times the quantity 2x minus 4 times the quantity x plus 5. So if I multiply by 3 first, I have to pick one or the other, right? Not both things to multiply by 3. So if I multiply 2x minus 4 times 3, that's going to give me 6x minus 12. Okay? Then from there, okay, I could use FOIL. If you want to use FOIL, that's totally fine. I'm going to demonstrate the distribution method here. So it's going to look like this. Okay? So this is going to give me 6x squared plus 30x minus 12x minus 60. Again, the middle terms are like terms, so we have 30 minus 12, which is 18. Okay, so notice if I toggle back to this page, right, we got 6x squared plus 18x minus 60. That is the exact same answer that we got here. Okay, so again, you could multiply by 3 first, as I did here, or you can distribute first. As long as you follow the correct rules, you will get the same answer. All right, so I want to make a note because in the previous section, we were working on adding and subtracting polynomials. And now we're looking at multiplying polynomials. And what can happen, right, is especially on a test where you have a whole chapter, right, or a whole module, many modules represented in a single assessment, people get these two confused a lot more often than you would think. Okay, so what is being done here? Well, all we're doing is adding. There is no multiplication, right? We would just have x minus 1 plus 2x plus 3, right? So we have x plus 2x, which is equal to 3x. We have negative 1 plus 3, which is 2. Okay, again, we're just combining like terms. That's it. Okay, over here, right, we would actually have to multiply. And again, I'm using the distribution method. Right, so it would look something like this. So you get 2x squared plus 3x minus 2x minus 3. Again, combining our inner terms, we get 2x squared minus, 2x squared plus x minus 3. So notice they are very, very different from one another. Okay. Similarly, what if, right? What if I had x minus 1 minus 2x minus 3? Again, so a lot of students, they will see this problem and they will try to multiply. But we're not being asked to multiply, are we? We're being asked to subtract. So what I would do here is I would put a negative 1, right? So it would become minus 2x plus 3. Again, combining like terms, I'm going to get negative 1x plus 2. So please, please, please be careful, okay? And look very carefully at your problem. Are you being asked to add or subtract or multiply, because they are completely different operations, right? And if you multiply when you're supposed to add or subtract or vice versa, right, you're going to get a completely wrong answer, and you're not even going to get partial credit, right, because there isn't any part of your procedure that was correct.